Hey everyone, welcome back to our channel. Today we are diving into something really exciting. We are going to create a cluster of MQTT brokers with entirely open source software packages. But before we get into the action, if you missed it, we recently made a video about getting started with EMQX MQTT broker, and that's what we are going to use in today's video. So if you are new here, go ahead and check it out and come back to make sure you can follow along. But for now, let's see what a cluster is, why we need it, how to set it up, and how our clustered MQTT brokers hold up under pressure. I know it sounds very complicated, but trust me, by the end of this video, you will learn how easy it is to build such a resilient system in a few simple steps. Before we jump into the hands-on sections to show you all the steps to set up your clustered MQTT broker, let's quickly review why clustering and another technology that we are going to use in this video called load balancing are crucial for any large-scale systems, including industrial Internet of Things systems. To understand the importance of clustering, imagine an industrial IoT system in manufacturing plant with numerous machines, sensors, actuators, PLCs, and so on. Of course, all these devices communicate with each other with different protocols, but nowadays we are using MQTT more than before. As you may guess, each node generates a significant amount of data that needs to be processed in real time to ensure a smooth operations. But relying on a single MQTT broker to handle all this data can lead to bottlenecks and ultimately system failures, disrupting production processes, and causing costly downtime. That's where clustering comes into play to minimize such risks. In simple words, clustering allows us to create a network of interconnected MQTT brokers that work together as a unified server or unified MQTT broker. By distributing the workload across multiple MQTT brokers, we ensure high availability, fault tolerance, and scalability. This means that even if one MQTT server or broker goes down, the others can seamlessly take over to keep the production line running smoothly. Think of it like managing a busy factory floor. If all machines are trying to communicate with a single MQTT broker, it's like having a traffic jam at a crucial intersection that no one wants. But by clustering MQTT brokers, we create parallel lanes of MQTT communication, ensuring that data flows smoothly, just like a well-oiled production line. I know I talked too much about the theory and concepts, but it was important to understand what we are trying to achieve in this tutorial. Now let's get into the fun and hands-on stuff to configure our devices and build our cluster and test it out. If you need a lot of information about the clustering in EMQX or perhaps any other MQTT broker, you can refer to their documentation. So here we are looking at the EMQX clustering architecture. As you can see here, in EMQX, in a clustered MQTT broker, different database instances will share different information together. And if you remember from our previous video, EMQX uses a database called Amnesia. I don't want to go too much into the details and the technology behind how the EMQX clustering works, but it's important to know, as we mentioned, a cluster consists of at least two MQTT brokers, or it can be way more, and overall the cluster acts as one single MQTT broker to manage all the data communications. So in today's video, I'm using my Siemens IoT 2050 as the MQTT broker number 1 and my Raspberry Pi 5 as my MQTT broker number 2 and a separate Raspberry Pi 4 as my load balancer. I will explain what the load balancer is and why we need it, but for now it's good to know we have 3 pieces of hardware. Of course, you could have all of these 3 or even more on a single machine as Docker containers or perhaps virtual machines, but definitely using separate hardware improves your system fault tolerance. Alright, so now that you are familiar with the hardware, let's configure our devices. The first step is all the MQTT brokers are on the same network and they can see each other. And we need to ensure that our MQTT brokers are configured as a cluster, not as a standalone MQTT broker. This involves configuring each MQTT broker to communicate with each other to form a unified network of MQTT brokers called cluster. I know this might sound very complicated, and to be honest, it is a complicated topic and a lot of things going on under the hood, but as an end user, we don't need to know what's going on behind the scenes as long as it gets the job done. So now let me show you how easy it is to create a cluster in EMQX. So first, we need to log into our MQTT broker servers. As I mentioned, I have them running on separate hardware, but for your case, it might be in a VM or a Docker container, but you need to have access to the terminal over SSH. That's why here I have 3 different terminals open to connect to my Raspberry Pi and IoT 2050, which are running my MQTT brokers. So to configure your EMQX MQTT broker as a cluster, all you need to do, you just need to go to this path. And as you can see, there is a file called emqx.conf. This is the configuration file for your MQTT broker. You just need to open and edit this file by a file editor such as Nano if you are using Linux, or any other text editor if you are using another operating system such as Windows or Mac. Okay, so here I'm just going to open it with a Nano. So as you can see here, I've already done my configuration, but the configuration is very easy. At first, we just define the different parameters of the node. You normally don't need to change this other than the IP address of your device, because at first and by default, this is based on the host name, not by IP address. And once you adjusted your IP address in your configuration file, you just need to add this section. In the cluster, you need to define different MQTT brokers that are participating in this cluster. In my case, I have one IoT 2050 at the IP address of 192.168.0.250 and my Raspberry Pi 5, which has the IP address of 192.168.0.104. And you can change the default port for the dashboard, or you can just leave it as default, which is 18.083. So that's pretty much it for configuring your first MQTT broker to participate in a cluster. At this point, you can save your work and exit the file editor. Now I'm moving forward to my second MQTT broker, which is a Raspberry Pi 5 in my case. So I just need to repeat the process and do the same configuration on my second MQTT broker. Again, as you can see, my second MQTT broker, which is a Raspberry Pi 5, has a different IP address and it has a section as a cluster, and different MQTT brokers are listed which are participating in this cluster. And I will leave the default port for my dashboard as it is. Now I can close my text editor and go back to the main page. Okay, just to make sure everything is configured properly, we can now log into our MQTT brokers dashboard and verify our cluster is up and running. Here I have 2 MQTT brokers, as I mentioned, one on Raspberry Pi 5 and one on Siemens IoT 2050. So I'm expecting to see 2 different nodes on my MQTT cluster. Now let's log into our dashboards. Okay, as you can see, I have logged into my IoT 2050, and as you can see at the middle of the page in the cluster overview, I have 2 nodes configured in this cluster. If I just hover my mouse over different nodes, I can see different information about my nodes. So for example, the first node is an IoT 2050. The IP address is 192.168.0.250, and I have a quick overview of my OS memory, CPU workload, and so on. And as you can see, despite the fact that my IoT 2050 only has 1 GB of RAM, this cluster is not even consuming half of my RAM. Of course, as we move forward and I get more traffic, this will significantly go up, but the cluster itself as the base doesn't consume that much resources. Similarly, I can see different parameters and information on my second node, which is a Raspberry Pi 5 with 8 GB of RAM, and as you can see, I have only one topic. the uptime, and different information. Again, please feel free to go over the previous video that we went through all the menu options to make you comfortable with using this dashboard. So similarly, I can just log into my second MQTT broker dashboard to confirm my node is showing correctly. Okay, as you can see here, I have the same view. I have two nodes showing up here. I'm very curious to see how this graphic looks like when we have too many nodes. And again, I really love the look of this dashboard. It looks very modern and solid, and it's packed with a lot of useful information. Congratulations! At this point, your cluster is up and running. You can test your cluster by publishing some values in one of your MQTT brokers, and you will see that all other MQTT brokers within your cluster get the same value. How cool is that? Okay, to test our cluster is working, I'm using the EMQX MQTT client software to publish some test values to one of my MQTT brokers, and if my cluster works well, I should get a copy of the same message in all other MQTT brokers because they are part of one cluster. You can use any other MQTT clients such as MQTT Explorer or any other choice of MQTT clients. So let me just log in to my first MQTT broker, which is a Siemens IoT 2050, and now I'm going to connect to my second MQTT broker, which is running on my Raspberry Pi 5. So let's just create a test topic. Let's call it test. I do the same on my other MQTT broker. Now from one of the MQTT brokers, let's say on my Raspberry Pi 5, if I publish a test value to the test topic, I should see the same value on my other MQTT broker. So let's just test it out. Hello from the Raspberry Pi 5. Because I have subscribed to this topic on my Raspberry Pi 5, for sure I see the result on the same broker. And let's just move to the second MQTT broker. And as you can see, I'm seeing the messages coming to the second MQTT broker as well. And that's how the cluster works. They get a copy of the message that happens in any of the MQTT brokers. So now let's publish another value from the other MQTT broker. So let's say hello from IoT 2050. And if we go to Raspberry Pi, I see the same message there. And that's perfect. And as you can see, configuring the cluster in EMQX is very easy. Okay, now you might ask, we have more than one MQTT brokers with different IP addresses. So what address should I use on my IoT devices such as a PLC or a microcontroller when setting up my MQTT communication? Because I have to assign one single server on my device. The answer is simple. We are not done yet. We need to set up a software called load balancer, and then you can use the load balancer's address in your devices such as PLC or a microcontroller, and then the load balancer will take care of the rest. To understand how the load balancer works, let's look at this simple diagram. So in our example, on the right side, we have different MQTT brokers. In our case, we had two MQTT brokers, and each MQTT broker has its own IP address. And to make sure we are benefiting from the clustering, instead of communicating with each of these MQTT brokers, we need to install a middle software or a load balancer. So our end devices, which on the left side, as you can see here, each of these can be an MQTT client software, a PLC or different devices, and these devices or MQTT clients communicate with the MQTT brokers through the load balancer, and it's the job of the load balancer to make sure the traffic goes through smoothly, and if one MQTT broker goes down, the other ones can take over. As you can see, the concept is fairly easy. I know you are very smart, and again you might ask, why should I bother to use a load balancer? What benefits do I get from a load balancer in my industrial Internet of Things system? Well, using a load balancer is like having supervisors overseeing different sections of the factory floor. They ensure that each machine gets its fair share of attention and resources. Similarly, load balancers distribute incoming data traffic across the clustered MQTT brokers, which prevents any single MQTT broker from becoming overwhelmed. Most importantly, as mentioned before, the load balancer will be the point of contact with your MQTT devices, so your device doesn't need to know anything about clustering. With the help of the load balancing technology, a clustered MQTT broker is similar to a single MQTT broker for any device. How cool is that? Okay, now that is clear why do we need a load balancer in our clustered MQTT broker setup, let's set up a load balancer for our cluster and see how it works in real life. There are several load balancers in the market, and you may choose a different load balancer that meets all the project requirements for your case. But today, I'm going to use an open source load balancer called NGINX, which is very popular and well known in IT environments. I don't want to spend time to explain how to install NGINX because there are just tons of videos on YouTube and different resources to show you how to install it on your choice of OS. But for now, I assume you have installed NGINX. It's just a couple of command lines that you need to enter to your terminal to install NGINX. It's fairly easy. But for now, we need to know how to configure NGINX to work as a load balancer for MQTT broker clusters. So configuring NGINX is also fairly easy to work as a load balancer, and we just need to change something in the configuration file, which you can find it under the NGINX directory. So let's just navigate to that directory and open the configuration file. And again, because I'm using Debian Linux, I'm just using the nano to edit my configuration file. Okay. To configure the NGINX to work as our load balancer, we need to define where are our servers located. So that's why I have listed the IP address of my MQTT broker servers, which are again my Raspberry Pi 5 and my Siemens IoT 2050. And in the server section, I'm just defining, or I'm telling the NGINX to listen to the port number 1883. That's the port that our MQTT communication goes through. Once the NGINX receives the request on this port, it will direct the traffic to different MQTT brokers, which we have listed here. So after the configuration is done, you can just save your work and close the editor, and that's it. Congratulations again, now you have a clustered MQTT broker with a load balancer, and that's what you see in a real-life industrial IoT system in the industry. And that's it. Now let's test our cluster with a load balancer. And for the test, I'm using my Siemens logo to publish some values to my cluster. I'm going to use the same project for my logo version 8.4 that I explained in the previous videos. So if you are curious how to configure your logo to publish some values into the MQTT broker, please check the other video. To make sure everything is working, I'm using again the MQTTX client software, and I have subscribed to the topic that my Siemens logo is publishing the data to. And I have subscribed to the same topic on both MQTT brokers that are a part of my cluster. So let's just connect to both MQTT brokers and see if we get the same message on both brokers. Okay, as you can see, the messages are coming to my first MQTT broker running on my IoT 2050 device. Let's just connect to a Raspberry Pi 5 and make sure that is working as well. Yes, as you can see, I'm getting the same messages on my Raspberry Pi MQTT broker as well. And to verify the performance of our cluster, let's just disconnect one of our MQTT broker, and if everything works well, we should still get the messages on the second MQTT broker, and overall our system shouldn't go down. So I'm just going to disconnect my first MQTT broker, which is running on my Siemens IoT 2050. You can see here, I'm just disconnecting my IoT 2050 from the network. So now, as you can see, I'm not getting any message in my IoT 2050 MQTT broker because my server is down. But if we check my other MQTT broker, which is my Raspberry Pi 5, I'm still receiving the messages in my MQTT broker, which is running on my Raspberry Pi 5. So there is no disruption in the work of my logo, and my logo is still publishing the values in my MQTT broker. Let's connect the network back to our Siemens IoT 2050 to see if the traffics are coming back online. Okay, as you can see, after connecting my second MQTT broker, which is running on IoT 2050, I'm receiving the messages on both MQTT brokers. And voila, as you can see, the cluster is working like a charm. So there you have it. I hope this video was useful and you learned how to improve the availability of your industrial IoT or IIoT system using clustering and load balancing technologies. Of course, there are many more things to talk about, but by now you should have a good understanding of clustering in the industrial IoT systems. Let me know what you think about clustering and load balancing. Have you used them before in your IoT project? And as always, until the next time, have a great day or night.